Solving equations by adding or subtracting. Our objective is to solve one-step equations using addition or subtraction. Why learn this? Athletes can use an equation to estimate their maximum heart rates. To be able to solve equations using addition or subtraction, we need to know what the inverse operations of those are. Inverse operations are basically the operation that is the exact opposite. So addition, the exact opposite of addition, is subtraction. The exact opposite of subtraction is addition. You're going to use inverse operations to be able to get rid of numbers. Let's look at a few examples. Solving equations by using addition. So we're going to solve each equation. To start, we want to make sure we know where each side of our equation is. It's not too difficult when you only have a few numbers, but when you get much larger problems, sometimes it's going to be much easier to know exactly which side of the equation is what. So we're going to divide our equation up right through the equal sign. So we have the left side of our equation and the right side of our equation. Now, our objective is to get this x, or variable, by itself, because that's what we're going to need to do to solve each equation. So, to get x by itself, we need to use the inverse operation. Well, the opposite of minus 10 is adding 10. Whatever you do to one side of the equation, you need to do to the other. You need to make sure you keep everything balanced. Well, you're left with nothing else over here but the x, because minus 10 plus 10 gives you 0. On the right-hand side of the equation, you have 4 plus 10, leaving you with 14. Let's double check our work. So if x equals 14, we're going to substitute 14 in for x. So 14 minus 10, does that equal 4? Yes, it does. So we're good to go. Take a moment and pause the video and try b on your own. Now that you've had a moment to try b on your own, let's try it together. So let's divide our equation into its two pieces. Okay, our variable is m and it's on the right-hand side of the equation. So we want to get rid of the stuff on the right-hand side of the equation to leave m all by itself. So we have minus 1/5, so we're going to add 1/5 to both sides. When we're done, we're left with 3/5 equals m. However, let's double check our work. Is 2/5 in fact equal to 3/5 minus 1/5? Yes, it is, so we're good to go. Let's try some more examples. Solving equations by using subtraction. So, we're going to do the first one together. We want to divide both sides of our equation, so we know which one's our left side and our right side. And we have x plus 7. We want to get x by itself, so we want to do the inverse operation of plus 7. Well, that would be minus 7. Whatever an inverse does, it's going to make this equal 0. Remember, whatever you do to one side of the equation, don't forget to do it to the other side of the equation. Very important to keep everything balanced. So we're only left with an x on the left, and on the right we have 9 minus 7, which leaves us with 2. Let's double check our work. We're going to substitute 2 in for x. So we have 2 plus 7 equals 9. Well, it does equal 9, so we're good to go. Take a moment and pause the video and try b on your own. Now that you've had a moment to try b, let's try it together. Let's divide our equation into two pieces, through the equal sign, not just anywhere, and we want to get r by itself. So we're going to subtract 0.4 from both sides of the equation. That leaves us with an r on the right-hand side of the equation and a 0.3 or 0.3 on the left-hand side of the equation. Let's double check and make sure we did this correctly. Is 0.7 in fact equal to 0.3 plus 0.4? Well, 3 and 4 make 7, so we have 0.7. It does. Let's get a little bit trickier. So we're going to do the first one together, and then you'll try the second one. So once again, we start by dividing our equation through the equal sign, so we know which sides are left and are right. Alright, we want to get b by itself. We have this minus 8 over here. Well, what's the opposite of a minus 8? Plus 8. Because adding 8 will make this 0. And if you have 0 of something, you don't have anything of it. So, it gets rid of it and it leaves b by itself. Whatever you do to one side of the equation, you have to do to the other. So make sure you add 8 to the right. Alright, so now we're just left with the b like we just recently talked about. And we have 2 plus 8. Well, 2 plus 8 is 10. Time to double check. So we have negative 8 plus, substitute 10 in for b. Does that in fact equal 2? Yes, it does. We're good to go. Take a moment and pause the video and try this next one on your own. Now that you've had a moment to try this next one on your own, let's try it together. So we're going to start by dividing our equation in half. Alright, so we want to get x by itself because that's our variable. So we want to move this minus 11 to the other side of the equation. And to do so, we're going to add 11 to both sides of the equation. Because it gets rid of it over here and it moves it to the other side. So now we have x equals 44. Always double check. Negative 11 plus 44. Does that in fact equal 33? Well, 44 minus 11 is 33, so we're good to go. Let's look at a fitness application. A person's maximum heart rate is the highest rate in beats per minute that the person's heart should reach. One method to estimate maximum heart rate states that your age added to your maximum heart rate is 220. Using this method, write and solve an equation to find the maximum heart rate of a 15-year-old. So we have age added to maximum heart rate is 220. Well, we need to start substituting some values in. So let's make it into an equation. So we have A for age plus, and then for heart rate we're going to use R for rate, equals 220. So we're going to start with, we have 15 years old, so we're going to substitute that into our equation here. So we have 15 plus R equals 220. We're going to need to subtract, because it's a positive 15, we're going to need to subtract 15 from both sides of the equation to get R by itself. Keep in mind, if you're having difficulty figuring out whether you should add or subtract, think of it this way. What do I need to do with this 15 to make it 0? If you were to add 15 to 15, you'd have 30. That's not 0, so that's why you're going to subtract. And when you do, you end up with R equals 205. Alright, so we have two properties of equality that we just learned. The addition property of equality. You can add the same number to both sides of an equation, and the statement will be true. So it doesn't matter whether you add 400 to both sides of the equation. If you add the same thing to both sides of the equation, your equation will remain equal. Same thing with subtraction. So you have the subtraction property of equality. You can subtract the same number from both sides of an equation, and the statement will be true. So if you subtract 5 from both sides of the equation, you're going to end up with the same number in the end, in this case 2. And that concludes our lesson on solving equations by adding or subtracting.